Welcome to qnawire.
So in this problem, we have been given a silver atom which has an atomic number of 47 and an electronic configuration such that it has one electron in the phi-s state. So the silver atom has spin 1/2 and it is placed in magnetic field of 1.0 Tesla, splits the ground state of the silver atom, and we have into two closed level, and we are supposed to find the energy difference between these two levels in part A. So in part A, so whenever an electron is placed in a magnetic field, the potential energy of that electron in a magnetic field is given by relation minus G mu P ms times Pz, where G is the gyrometric ratio, which is 2.0 2.0023 for electrons. So let's write that out. 2.0023 mu P is the Bohr magneton, which is 9.27 times 10 to the power minus 24 joules over Tesla, and ms is the spin of the electron, which can be either up or which can be either 1/2 or minus 1/2, and Pz is the z component of magnetic field. In this case, it is just 1 Tesla. So let's consider first when the electron spin is up, we have 2.0023. Let me just write, instead of plugging in the values for everything first, let me just write when the electron has half spin, it has kinetic energy minus G mu P times 1/2 Pz. When it has minus 1/2 spin, so the potential energy is 1/2 minus 1/2 Pz. So the change in the potential energy, or the splitting of the energy level, is just U of minus 1/2 minus U of 1/2. So we have, if we go back to the previous slide, we have U of minus 1/2. So we basically get G times mu P times B. So we plug in the values for G, which is 2.0023 times mu B, which is 9.27 times 10 to the power minus 24 joules over Tesla, and we convert these joules to electron volt using this conversion, minus 19 joules over electron volt times 2.5 Tesla. Since we had on this part this Tesla, so the difference in the energy level is 2.9 times 10 to the power minus 4 joules. Joules cancel, Tesla cancel, and we get electron volt, which is the unit of energy. Now for the next part, let's move on to the next slide. For the next part, they have asked us to calculate the wavelength of the photon caused when it makes a transition from the lower level to the upper one. So let's call this B, part B. What wavelength photon is emitted when the atom goes from lower level to the upper one? So then delta U is just equal to the energy of photon emitted, which is just HF, which is HC over lambda. So lambda is Hc over delta U. We already calculated delta U, which is which is which is basically incorrect here. The answer is, sorry for that, delta U is 1.16 times 10 to the power minus 4 electron volt. And then we move on. So we have 1.16 times 10 to the power minus 4 electron volts, and the value for H is 6.63 times 10 to the power minus 34 joules second. C is in 3 into 10 to the power 8 meters per second. And in order to cancel the electron volt with joule, we use the conversion formula 1.609 10 to the power minus 19 joules over electron volt. So electron volt cancels, joules cancels, second cancel here. So the lambda value comes out to be 1.072 times 10 to the power minus 2 meters, which is basically 1.072 centimeters. Now, in the third part, they have asked us to, in the third part, part C, the question is how would the answer differ if the atoms were hydrogen atom? So the atomic configuration for hydrogen atom is 1s1. So this basically means that it has a one electron which has spin 1/2 and is not paired to anything, whereas the atomic configuration for silver atom is 5s1. The outermost electron has electronic configuration of 5s1, so it also has the spin of 1/2. So the splitting for both atoms will be the same due to the s state of the electron. It would not be any different.